Good morning everyone. I am Tanushri Dalai from Civil Engineering branch and today I am going to teach you your Theory 1 paper which name is Structural Mechanics. So in the last class we have calculated the value of shear force and bending moment of a simply supported beam subjected to a point load at the midspan of the beam. And today we will calculate the value of shear force and bending moment of a simply supported beam having UDL at the all span of the beam. So you can see here, this is your beam and it is simply supported by two supports at the end of the beam, and on the beam the total UDL will occur from the first end to the last end. So here, first of all, in case of simply supported beam, we need to calculate the reaction calculation, then shear force calculation, then bending moment calculation. So for the reaction calculation, we have to equilibrium the beam as per the upward and downward forces. So I told you in the last class, here the end supports is acting in terms of reactions. That means this is the point A and this is the point B. So at point A, the reaction will be RA and at point B, the reaction will be RB. So these are two upward forces and the UDL is acting all over the span in downward direction. So we can say RA plus RB is equal to UDL load. So here the UDL will be W per unit length. So to calculate the total load of the UDL, or we can say to convert the total load of uniformly distributed load into point load, we need to multiply the load of the UDL into the total span of the beam on which the UDL is acting. So here you can see the total length of the beam is L on which the UDL is acting. So the total load of UDL is W into L, that is load into distance. So we can write the total downward forces, that is W into L, is equal to total upward forces, which is two reactions. One is RA and second one is RB. So here RA plus RB is equal to total load of the UDL, which is W into L. Next one is, for the value of RA and RB, we need to calculate the moment calculation about the point A or B, that means any end of the beam. So here we are considering the point A, that means this point. So first of all, if we consider the point A, we need to see at the right side of the section and what are the forces acting here, and to calculate the value of RA and RB, we need to put all these value here. So first of all, for this reaction value, we need to calculate the moment up to the point A. So what is the formula? First of all, load into distance, because it is a point load, so that the formula is load into distance. So here load is RB and distance is up to A, that is L. So RB into L is the moment for reaction B to the point A. So RB into L, and the sign will be positive because it is giving a sagging moment towards the point A. Then the next load is UDL. So to calculate the moment for the UDL, I told you in case of cantilever, in case of UDL, the moment calculation will be load into distance by 2. So that here your load is W and distance up to this point will be L because the UDL is acting all over the span. So the total distance is L and distance by 2, that is L by 2. So here we can write W into L by 2. And the sign is negative in nature because this UDL gives a hogging moment towards the point A. So that RB into L minus W into L by 2 is equal to 0. So from this equation, we can calculate the RB value as WL by 2. So if we got the value of RB, then we can easily calculate the value of RA also, because the total value of reactions is equal to WL and RB we got WL by 2. So your RA value will be WL minus WL by 2, by which we can get WL by 2, which is the value of WA. So from the reaction calculation, we found out that RA value and RB value, which is equal to WL by 2. So now we can calculate the shear force of the salient point of this beam. So first of all, we need to subdivide the whole span of the beam into two sections. So first of all, span AC, and second section will be span CB. So in case of span AC, the shear force at point A will be the reaction at point A, which is WL by 2, which we have calculated from the reaction calculation. So at the point A, the shear force is WL by 2. Then at point C, that means here the shear force value will be WL by 2 because the shear force at point A will be continue toward the point C. So that the shear force at point C is same equal to shear force at point A, which is WL by 2. So now the second half of the section, which is span CB. So first of all, shear force at point C. So here first of all, from the span AC, whatever the shear force at point C, we put here first, that is WL by 2, and after that the UDL we have to consider. So the UDL value is W into L, that is the UDL we have already converted into point load, that is W into L. So we deduct this portion from the WL by 2 because in span CB, if we draw a section here, then the UDL will be at the left side of the section and downward in direction. So according to the shear force sign, it is negative in nature. So by deducting WL from WL by 2, we will get the value of shear force at C as minus WL by 2. Then again, this shear force at point C is continuing towards the point B, which is minus WL by 2 again. So in this way, your shear force calculation is over. So now comes to the bending moment calculation. As we know that it is a simply supported beam and the two ends of the beam is supported over two support, so that here only load is there, or you can say reaction is there, but no distance is there. So for that, the bending moment at point A will be 0 and bending moment at point B also 0, because here only reaction is considered but no distance is there. But to calculate the moment, we need to know two things. First one is your load and second one is your distance. So after that, we need to calculate bending moment at point C. So we can calculate the bending moment at point C from the right side or left side of the section. So here you can see we are considering the right side or left side of the section, but here we are considering the left part of the section. That means the point C, we need to look at the left side of the section, that means this portion, and what are the load acting here we need to know. So you can see here one reaction is there and second one is here one point load is there. So for calculate the bending moment at point C, we need to know two things. One is load and second one is your distance. So first of all, we will calculate the bending moment for this reaction value. So this is the reaction at A, which is RA. And for this force, the distance up to the C is L by 2. So we can say the load into distance will be RA into L by 2. That is WL by 2 into L by 2. So here WL by 2 into L by 2. Again, due to it is a UDL, so that the total calculation will be W into L, that is WL square, divided by 2 into 4. So this L by 4 is your UDL distance. That means W into L by 2. So the L by 2 is formed at the midspan of the beam. So the half of the L by 2 will be L by 4. So that here written as W into L by 2 divided by 2. So the total bending moment of the point C will be WL square divided by 8. And it is positive in nature because it is giving a sagging moment towards the point C. Hence, the bending moment at point C will be WL square by 8. So according to the points, these are the shear force diagram and bending moment diagram. So today this much. Thank you.